Here we're going to take a look at triangle proportionality. And we're going to build this as a construction and get the whole argument from what we start with, which is this first triangle ABC. And I want to be able to build a proportional triangle. So I'm going to choose a point on AB and I'm going to label that point E. So what I'm going to try and do is build a proportionally smaller triangle within the ABC. So I'm going to recreate this ABC angle at E, so that AE, and then I'll put F over here, will be the same angle as the angle at B. In order to do this, I'm going to just simply create an arc at B and that same arc at E. Once I have that arc built from the intersection on the BA line, I'm going to measure it with my compass and transfer that measurement up to the intersection above E. And at this point, I'm going to very carefully connect that intersection with E. This new line, EF, is parallel to the line BC. Now, this transversal, when I create these two angles that are parallel, that are congruent, what I'm actually using is the converse of the corresponding angle theorem. So back to parallel lines and transversals, what I'm able to find is that by building those corresponding angles, then I know that these two lines are parallel to each other. What does this mean for me? This means that AE compared to EB is going to be compared with AF and FC. So I'll be able to wind up seeing that there's a proportionality of these sides. What this actually is giving me is the proportionality theorem, saying that AE over EB as a ratio is equal to AF over FC. And this is all because these two lines are parallel. The converse of this is that if I'm given where these ratios exist, the AE over EB and the AF over FC, if these ratios exist, then these two lines are parallel to each other. Now, I often tell students to think about this as this is AE and EB. These are parts. You could also deal with it as an AE, AB, a large and a small. So let's take a look at an example of how we could use this. What if I had a triangle like this ABC triangle here? And within this triangle are parallel lines. And then I'm given segment lengths of 4, 9, and 10. Could I find this missing side X? So in order to find this missing side X, what I know is that from here to here, and we'll call this point D, that AD over DB is equal to AE over EC. So I can simply substitute some values in here. AD is a 9, DB is a 4, AE is a 10, and EC is my unknown X. So I'm going to just simply solve as any proportion. I'm going to get 9X equals 40, or X equals 40 over 9. Now I could simplify this, but since it's still going to wind up being a fraction, I'm going to go ahead and leave it with just that. Remember, math rocks with a capital M.